Routing is responsible for matching incoming HTTP requests and matching those requests to apps' executable endpoints. Endpoints are units of executable code that handles requests coming to the application. Endpoints are defined when the application starts, and the URLs to these endpoints can be generated from the information in them. In this video, let's learn about the underlying concepts of routing in ASP.NET Core. Hello everyone, if you are new here, my name is Rahul and welcome back to the YouTube channel. Let's head off to the console and create a new .NET web application to understand more about routing. Let's use the .NET CLI and use the new and the web template to create a new web application. This will create an application in the current folder. Open this up in the IDE of your choice. In this case, I'll use Rider. The application is loaded up in Rider, and you can see there is a program.cs file and a startup.cs class. All ASP.NET Core templates includes routing in the generated code. Routing is specified in the middleware pipeline. In an earlier video, we saw more about routing in ASP.NET Core and how to configure that. Inside the startup.cs class, under the configure method is where we define the middleware pipeline. Here, we see that this template already has app.useRouting and the app.use endpoints call. This is setting up this application with the routes and the endpoints that's required to handle the request. Use routing adds route matching to the middleware pipeline. This middleware looks at the set of endpoints defined in the application and selects the best match based on the request. Use endpoint method adds endpoint execution code to the middleware pipeline. It runs the delegate associated with the selected endpoint. By default, in this template, we can see the use endpoints has one endpoint configured. Here, we use the map get method to handle any request that matches to the root of the request and then calls in to the context.response and writes a hello world. Let's run the application and see this in action. Here, we are hitting the root of the application and we get back a hello world. If we were to pass in any other value, it doesn't get matched and we have an HTTP error 404. This is because there is no matching endpoint for this particular request. The map get method is defining an endpoint in this application. An endpoint is something that can be selected using the URL and the HTTP verb. The endpoint also has an associated piece of code which is defined as part of this delegate and it writes back into the context.response. This is why when this endpoint is getting selected, based on the routing, it is writing back hello world to the response. Similar to the map get method, we have endpoints.mapPut, the map post, map delete, etc. You can use these methods to map to the appropriate HTTP verb requests. The route template is used to configure how the endpoint is matched. Let's see an example. Let's add a new endpoint to this application. So using the endpoints and the map get method, we can specify a new route template. In here, I will say /hello. So this gets matched when the URL is to the /hello endpoint. So let's specify the async context and also specify the delegate handler to simply write back to the context like before. Let's write back to the context.response and call the write async method and say hello. So this is going to write back hello whenever we come to the /hello endpoint. Let's run this and make sure this is working as expected. So when it's hitting the root endpoint, it gives back the hello world. And when I specify /hello, it's going to hit the hello message. So this is working as expected now. So let's say we want to add a parameter to this particular route. In this example, let's say we need to add a name. So let's specify / and use the brackets to specify a parameter. So this is going to take anything that's after /hello as the name parameter. To retrieve the value of name from the route template, let's specify a new variable var name and use the context, the getRouteValue method and call in name. So this is going to return back the name from the routes. Let's use string interpolation and pass back the name with the hello. So in this case, it's going to specify hello and the name. Let's run the application again and see if this works as expected. So let's specify hello and specify Rahul in this example. So we get back hello Rahul. Now that we are able to get back the name, let's say we want to add a constraint on this route saying this name should only be alphabets. So currently, I can specify 123 and I'll get back hello 123. So let's add a constraint so that this doesn't work anymore. When specifying the route template, we can add in constraints using the colon operator. Let's specify colon and say alpha, which represents only alphabets. So now if we were to run this application again and go to hello/Rahul, this is going to work as expected. So this returns back hello Rahul. However, if I was to specify 123, it says HTTP 404 because there is no matching endpoints for this particular route. We have now a constraint for alphabets, which is why this is not getting matched. Even if this was to start with Rahul, this doesn't get matched because it has integers in this particular name. Currently, specifying a name is mandatory and is not optional. So if we were to completely remove the Rahul, it's again going to throw an HTTP 404. But let's say we don't want this and we want to make this parameter in this template as optional. To do that, let's add in a question mark in the end of the route template. So here we can specify name colon alpha and specify a question mark to say that this is optional. If we want to add more constraints, let's say this needs to be alphabet and should be of minimum length of at least 2 characters. So we can specify an extra colon and specify minimum length as 2. So in this case, this specifies that the name should be only alphabets, it should be having a minimum length of 2 and is optional. So let's run this and check if this is working as expected. So now if I go to the hello endpoint, it's returning back just the hello because the name is empty. Now if I specify Rahul, it works. If I specify 123, it returns a 404 because there is no matching route. And if I specify just letter R, that is also going to fail because it doesn't match the minimum length criteria. So I need to specify at least 2 characters. So let's say R and A, and that will start matching the name. The documentation has the route constraint references. So these are the allowed values that you can use inside the curly braces. So specifying int makes that as an int only, bool similarly, and so on. So you can look at the various options that you can specify as a route constraint. You can also use regular expressions to add constraints to your route parameters. If none of these works for you, you can also add a custom constraint. Let's see how we can do that. So let's go back to the source code. Let's add in a new class, my custom constraint. So this is going to define a custom constraint. To do that, I have to implement an interface iRoute constraint. So let's implement that and also implement the missing members. So this is going to give us a match method which has a route and the route key and a list of values. So let's use that to start writing our constraint. So first, let's get the value for this particular route. So using the route key and the values, we can specify the values.tryGetValue, specify which key we are looking for, which is also coming from this method. So let's specify that and get in the value as out object value. So if this value exists inside the values collection, let's start adding some constraints. So we want the value as a string. So let's use value is string and specify that as a string value. So this is going to give in the value as a string value if this matches to be a string type. If not, it will simply go back. So if this is a string value, all we care about in this case is whether it starts with a 0 or not. So let's specify that and return that value. So if this particular string route key starts with 0, it is a match, but if not, it's not. So to specify that it fails, let's return a blanket false at the end of this method. So anytime the route is starting with 0, it's going to get matched. To specify this as a constraint, let's go back to the startup class and first register that inside the configure services method. Let's use the services and use in the add routing method and take in the options that it provides and add the new custom constraint. So using the options into the constraint map, we can add a new value, use a key. So let's say my custom, which will be used as the route constraint parameter, and also specify the type of this particular constraint. In this case, this is the my custom constraint that we just wrote. So this has added the my custom constraint into the routing list. Let's come down to the configure method and start using this new custom constraint that we have written. I already have a new endpoint written, so let's use that. So this is adding a new endpoint, which is /custom, passes in a name which has the constraint my custom added. It gets in the name and returns back hello from custom. Let's run this and verify it's working as expected. Let's go to the /custom endpoint and specify a name that starts with 0. So that is working. If I was to specify something without starting with 0, this is going to again say HTTP 404. This is because the custom constraint mandates that anything after that, which is the name, is going to start with a 0. So if I say 0 and hello, this is again going to work. And also 0, 1, 2, 3 because we don't have any integer constraints on that particular route. The routing system, as we saw, builds on top of the middleware pipeline. An ASP.NET Core endpoint is executable, which means it has a request delegate that executes when that particular endpoint is matched. It's extensible using the metadata collection, which we will see in a while. It's selectable. This is what is being able to select based on the routing information. And also it's enumerable, which means you can list the collection of endpoints that you have. Let's see some of this to understand it better. To get the current endpoint that's matched for a request, you can use the getEndpoint method on the context object. To see this in action, let's add a new middleware between the routing and the endpoints call. Let's specify a new middleware using the app.use method, take in the context and the next middleware in this particular pipeline, and then use the context and the getEndpoint method. This is going to return us the next endpoint. Since we don't want to block this pipeline, let's call the await and call on to the next. Since we have an await, we need to make this whole as async. So let's add in the async here. So we have a new middleware which is going to call the getEndpoint. Let's store this to an endpoint variable. And we can inspect this while the application is running. Let's run the application to see how this works. The app has started and it has hit the breakpoint. So here we are calling on to the HTTP context and the getEndpoint method. If I was to step over, we can get the endpoint values that's currently being selected. So that is the route endpoint, which specifies that it is on the / and an HTTP GET. If we expand this, we can see the other information that's associated with that particular endpoint, which also has the request delegate, the route pattern, and other metadata that's associated with it. Since the route is on a /, it now returns /. So if we leave this and make a call to the /hello endpoint, we are going to see that in there. So let's use the /hello, and this is again going to hit the breakpoint. So let's step over like before, and we can see the endpoint is now representing the /hello /name and the minimum length pattern that we had written. This also specifies the request delegate and other information that's associated with it. If we were to write the same middleware before the app.useRouting method call, this endpoint is going to be null because the routing middleware is not yet set up. So if we were to put a breakpoint here, this is going to be null. So let's run this and make sure it is as expected. So this hits the first middleware that we wrote. So if we were to step over, we can see that the endpoint is currently null. This is because the routing middleware has not yet been set up for this pipeline. So once we go over and hit the next breakpoint, you are going to see the endpoint values populated as before. So any middleware that's running after the use endpoint call can inspect the endpoint and take appropriate action. So let's say, for example, the map get on the root URL, we can specify that this endpoint requires authorization using the require authorization method. So specifying that is going to add in extra metadata to that particular endpoint. So let's remove the first breakpoint because that's anyways going to be null and run this application. It hits the root URL and we have the endpoint here. So let's step over and inspect that. Inside the endpoint, we can see the route pattern is the / where we specified the use authorization. Under the metadata, we can now see that there is an authorization attribute getting added. So this is used by the authorization middleware to detect if this endpoint requires authorization or not and act accordingly based on the authorization policies that you have set for the application. Since I have nothing set, this is going to throw an exception. So this says it contains authorization metadata, but a supporting middleware was not found. Once you set that up, this will start working and start authorizing the user who is making this particular request. For now, since I don't have any specified, let's remove the require authorization call. URL matching is the process by which the routing matches an incoming request to an endpoint. It uses the data in the URL and the HTTP headers to match the appropriate URL. This could be extended to use any property inside the request. To match the incoming request, this first gets all the endpoints that's defined for the application and chooses the best matching URL. Let's see a couple of these examples. So here we have a /hello and a name getting specified here with constraints. But if I was to override this and add in a new endpoint, let's say mapGet, and specify that as /hello and give in a Rahul name. So this is going to match this particular as well and this endpoint as well. Let's make the response a bit more specific. So let's say specific match. So let's see how this is going to work. The application is running, so let's specify that particular URL, in this case hello and Rahul. So this is going to match the specific endpoint that we wrote for the hello Rahul endpoint. If this was to be a different name, let's say Rahul Nath, it's going to call the next endpoint, which is generic and has this particular template parameter in here. However, note that the /Rahul, which is more specific, took precedence over this endpoint in this case. If there are multiple matches for the exact same URL, then it is going to throw an exception because it cannot choose between them. To see that in action, let's specify the same URL twice. So I have two endpoints defined, which is /hello Rahul. Let's run this again and call the /hello Rahul endpoint. Now you can see that this throws an ambiguous match exception because it has multiple endpoints. So let's remove that so that this exception is not thrown anymore. The order of how we define these endpoints does not matter on how this gets matched. So even if the hello Rahul was below this particular endpoint, it's going to get matched when that specific URL is going to be made. There are more rules that goes into how these endpoints are getting matched. If you are interested, you can take a look at the documentation, which will be linked below. Now that we have seen the basics of the routing and how a routing template is defined and overall how a routing works, let's go into specifics and see how this works with controller endpoints. This might be the case when you're using an ASP.NET Web API or even maybe an MVC application. For this demo, I'll just add a controller. So let's add in a new folder inside the routing and add a new directory. Let's call this controllers, very similar to how the new template would have created a controller. Let's add in a new class, myTestController. To get this to working, I need to inherit from controller base. Let's add in a get method, specify a name, and return back the string, which is string interpolated, and specify hello from controller and give in the name as well. So this is going to return that particular name. Let's mark this with the API controller attribute and also add in a route which specifies the controller name. To specify that, let's use the square bracket and specify controller. Since there is a name, let's also add the HTTP GET attribute on top of this method and specify a route here which takes in the name value. To configure this controller, let's go back to the startup. Under the configure services method, we can add in the controllers using the services.addControllers method. So this is going to register the new controller that we just added into the dependency container of ASP.NET Core. If you're new to dependency injection in ASP.NET Core, check out the video linked here for more details. To map this particular controllers, inside the use endpoints, we can call in the map controllers method to map those controllers that we just added. So this is you're going to use a convention and find this particular controller. Let's run this and see if this works as expected. The application is running. If we go back to the code, the map controllers is using convention to map these controllers into the endpoints. So the convention it uses with this particular route specification is that it needs to use all the names in the class without the controller part. So in this case, this route is going to be myTest and we need to pass a name. So let's go back and call in to that endpoint. So let's say myTest and pass in the name Rahul. So this is returning hello from controller and giving in the name Rahul. If you don't give the name, this is going to give a 404. If we want to make the name optional or add constraints, we can do that here as well. So like we saw, we can say this is going to be alpha and also this is going to be optional. So these are going to add the constraint to the name parameter. Let's run this and see if this is working as expected. So let's go to myTest and hit Rahul endpoint. This works as before. If I was to specify 123, this is now returning an HTTP 404. This is because it doesn't match the route constraint that we just added. Even if we remove the parameter, since we marked it as optional, it now returns back just the hello from controller. because the name is empty. I hope this helps you to understand more about how routing works in ASP.NET Core. What we have seen here is the underlying concepts of how routing works. I've also shown how it translates to an example for a controller endpoint. We will see more details specific to these applications like Web API controller and how you can use routes in a separate video. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please make sure to subscribe. Thank you and see you soon.